Hello, learners. Hope that you are keeping well. Today's lesson is climate and weather, and we're looking at tropical cyclones. Okay. Now, obviously, we're going to look at the general characteristics. And if you refer to my lesson on mid-latitude, it's more or less the same sort of concepts we're going to look at, but base it on the tropical cyclone, areas of formation, conditions necessary for formation, stages in the formation, associated weather patterns, impact on humans and environments, precautionary measures and strategies that can affect tropical cyclones, identification on synoptic weather maps, okay, and one recent tropical cyclone, okay, that has taken place. Okay, now let us start looking at this. Okay, what we need to look at, and I'm going to skip this first, is the characteristics, the general characteristics of this tropical cyclone. All right, tropical cyclone is one of the names which is given when it takes place in the Indian Ocean. Alternate names: hurricane in the North Atlantic around the United States, etc. Typhoon in the North Pacific, where you talk Japan, etc. So we're using the word tropical cyclone because it's the Indian Ocean, and when tropical cyclones hit parts of Africa, parts of Southern Africa, etc., it's known as tropical cyclone. That's why we put it as big. All right. Tropical cyclones develop at the ITCZ, but outside the 5 degrees north and south. All right, outside. I'll talk about that. So when we get back to our point here, it occurs in these regions here. Okay, in these regions on either side of the equator, or tropical cyclone or intertropical convergence zone. All right, so it happens here. So it's associated with the easterly trade winds that take place in this place. Okay, but then we mentioned not 5 degrees north and south from the ITCZ or equator. Why is that? Because a Coriolis force is absent in those areas on the equator. Now, generally we stop at that. But why? Why do we need a Coriolis force? Firstly, the Coriolis force causes the deflection of winds. All right, if we look up here again, look at what's happening here. The Coriolis force is causing the deflection. All right, and it's moving then east and of course to west, east to west. It's causing that deflection. All right, and what do we need the deflection for? Because when it gets deflected, it allows for a cyclonic movement. All right, it allows for a cyclonic movement. All right, so what do we mean by cyclonic vortex, rather? Okay, what happens when it turns there? Okay, I'm going to skip, I'm making a mistake here. You understand? It allows for a low pressure to take place. Also, if I go back to my thing, the Coriolis force will cause the winds to spiral, okay, towards this vortex. Okay, so what happens here is that when these things starts getting deflected, all right, it'll cause the winds to start spiraling. So first the vortex, because a bit of a disturbance will be created when it deflects. Okay, that's a low pressure. And of course the low pressure is there, and this will cause a spinning, all right, of the air towards the low pressure. So we need this deflection of winds that must take place. All right, it must take place. So it'll cause the vortex, the low pressure, and it'll cause the spinning or rotating of the system around the low pressure. Okay, then an intense low pressure storm which causes a lot of wind and flood damage. That is a characteristic. Lots of flood damage. You can imagine the disaster to human beings. So it has to become intense, means the pressure in the center will keep decreasing. In fact, it goes sometimes way below 1,000 millibars, 950, 960 millibars, very low pressure in the center. So air moves in at a fast pace or circulates and towards this low pressure at a fast pace, bringing in strong winds and a force will take a lot of water because it takes place over the oceans and causes massive, massive damage. Tropical cyclones can only form under specific conditions. Well, thank you for that. Otherwise, we'd have tropical cyclones every day and we would have problems, just total destruction along coastlines, etc. And I will discuss this later in the presentation. They also named alphabetically, all right, alphabetically, in the season they occur, in the area. Like, for instance, Tropical Cyclone Dave. That must be a very good-looking cyclone. All right, Tropical Cyclone Dave will be the fourth cyclone, A, B, C, D, fourth cyclone in the area. Okay, that's how they named alphabetically for that season. Of course, the next season, it'll start again. All right. The main source of energy is latent heat, which results from cooling and condensing of air. First, there has to be high temperatures, but the main source is latent heat, because as air cools, it gives off heat and it makes it hotter, more air rising, and of course, the pressure decreases in the center. Tropical cyclones occur in tropical regions over warm oceans. So warm oceans, you understand, there has to be rising of air to create this low pressure. They move from east to west. Can you see the movements here? East to west. Some people say northeast to southwest, but the general direction is east to west. All right, they originate in summer and autumn, okay, mostly in late summer and early autumn. All right, of course, the temperature must be at least 26.5 degrees Celsius. I'm going to repeat that. And you notice the effect, because they move from east to west, they generally affect the eastern sections of countries, okay? And they start off happening around those tropical regions, you understand? And they move through, okay, from east to west. All right, I'm going to repeat some things, at least it reinforces what I am saying. All right, let's look at conditions necessary for the formation. Large sea surface area with temperature higher than 26.5 degrees. So there must be high temperatures for the earth to start rising to form this vortex of low pressure in the middle. Otherwise, air is not just going to move towards it. All right. And we spoke about presence of Coriolis force enough to create that cyclonic vortex, and also starting to spin around it or rotate around it. Okay, small variations in the vertical wind speed. Okay, in terms of wind speeds happening, because what's going to happen? If the wind speeds happen, it's going to disrupt the movement of air upwards. Okay, so it must be more calmer in terms of wind speed. All right, so that it doesn't disrupt. A pre-existing weak low pressure area or low level cyclonic circulation. There must be some sort of low pressure in the area. Upper air divergence above the sea means air going up and diverging. As it goes up, it cools, condenses, forms clouds, and divergence occurs. Because if divergence doesn't occur, we're not going to have this high pressure in the, or low pressure in the center. So if I draw something here, I'm just going to draw it briefly. Okay, there's a low pressure and air is rising, okay, in the center from that low pressure. And we do need upper air divergence also, okay, because it doesn't happen. We're going to find more and more air is going to come in here, and this low pressure is not going to develop very well. A good source of latent heat, because this pressure must go more and more down in terms of pressure readings, and therefore it has to add more heat here. So as the air is rising, it is cooling, it's giving off heat, and when it's giving off heat, it's resulting in more air rising up. You understand? Going up, decreasing the pressure down here. So the pressure is going lower and lower, and the low pressure is becoming more and more intense. And as it becomes more and more intense, you find the pressure gradient is now steeper from the outside to the inside. Air is rushing in and circulating towards a low pressure at very high speeds. Sometimes we can talk 250, 280 kilometers or even more per hour. Okay, so we need this latent heat to cause more air to rise, higher temperatures. Okay, and as I said again, ocean temperatures, I seem to like this one, having 25 degrees Celsius or more. I repeated it there. All right, is a source of moisture. Okay, so when the temperatures rise, more heat rises. You understand? More condensation, more latent heat. So therefore, more source of moisture would feeds into the storm as it's rising. You understand? The condensation of moisture releases enough latent heat of condensation to drive the storm. There's high humidity and condensation happens with it. So it drives the storm in the sense that it makes the vortex more stronger and more air rushes towards the center low pressure trough. All right. And of course, we need calm conditions, learners, because if it's not calm, you understand, in terms of your horizontal, etc., it's going to mix the air. All right. And it's going to disrupt that vortex from intensifying. Okay, because air will mix. I just drew a little sketch here, which shows you how the moist air over the ocean will move. All right, water vapor rises. As water vapor rises, it cools and condenses. Condensation releases heat. That's your latent heat. All right, the warm air continues to rise. Okay, because there's rapid rising of air. And imagine as it rises and condenses, what's going to happen? Huge cumulonimbus clouds are going to form as it rises. Okay, just a brief thing showing you that. All right, let's go on. Let's look at the stages of this. So we start off with the formative stage, all right, where it starts to form. Okay, now in the formative stage, the cyclone has very strong updrafts, meaning the air is rising. All right, it's rising from the surface of the sea. Okay, so because the temperature is above 26.5 degrees Celsius, and the low pressure intensifies. So there was a low pressure here, which was pre-existing, not creating much hassle because it was there. It was a bit of a low, not as intensive trough. And what happens as this high temperatures cause this air to rise? What happens to this low pressure? It intensifies. It gets more intense. The pressure is dropping. All right. At this stage, the cyclone is not very large as yet, okay, and there's no clear eye. I'm going to talk about the eye that's found in the center. Okay, I'll talk about it as we go through. Okay, so there's no clear eye. This is found in the center of that, where the trough of low pressure is. As the air moves up, we call that the eye. I will show that into your cross section. The wind starts spiraling. Obviously, it's going to spiral inwards. Can you see it starting to spiral inwards because the low is getting more intense? So they start moving And circulating, obviously, this is southern hemisphere because it's moving clockwise. All right, so it's moving in. Okay, and therefore now the pressure is slower, more spiraling air will start. Pressure generally above 1000 millibars. It's not that intense yet. Okay, you can see it here in the so-called eye, the temperature is above 1000, generally speaking. All right, so there's not massive movement, but it's starting to form, and the spiraling movement towards the center is starting to happen. Then we have the immature stage, all right, where now the very strong updrafts of air increase. Can you see it? It starts to increase now, updrafts, because the temperature increases due to release of latent heat. So the temperature here above 26.5 degrees Celsius, air starts to rise. As the air rises, it condenses and gives off this latent heat. Now what's happening to the temperature? It's getting even higher and higher and higher. All right. And what's happening as the temperature gets higher? More air is rising. What's happening to the pressure down here? It's becoming lower and lower. All right. And you can notice here the eye starts to form. This vortex becomes more intense. Can you see it's getting smaller? So it's become intense, and that's when we call it the eye. It starts to form. And the pressure in the center drops now below 1000 millibars. Can you see it's dropping? And when it's dropping, what's happening to the spiraling air, spiraling towards the center? It's becoming faster and more intense. Okay. And then, of course, we have the mature stage. All right, the big one. Here, the pressure gradient is very strong. Look at what has happened to the pressure reading here. In this case, it's 956. The pressure has really dropped. So from the outside to inside, the pressure gradient is massive difference. It's steep. You understand? So imagine the air now. It's moving at much faster speeds. As we say, depending on the category of the tropical cyclone, if it's category 5, it's very fast. Pressure is very low. Air is spiraling at speeds towards the center. 250, 300 kilometers an hour. All right? Massive. The speed of my car. I'm just kidding. All right. And the wind speeds reach hurricane strength. Very, very fast. All right. The calm, clear eye is well developed. The eye is calm. All right. Because air is rising there and condensing on the sides. But I don't want to disturb. Just remember the eye is calm. All right. I want to show you on a cross section as we go through. I don't want to mix up things and it's going to confuse you. The pressure is well below 1000 millibars, well below. All right. The forward left-hand quadrant, this one here, some people call it the dangerous semicircle, because remember the cyclone is moving from east to west. And this is the southern hemisphere, as I say. This forward left-hand quadrant down here is your most dangerous and most destructive and intense. Winds and cyclones combine here. You understand? So why is it intense? Okay, there's strong winds already, plus it combines with the force of the entire cyclone behind it. Fast winds combined with the entire force of the cyclone behind it makes this section or this piece, the forward left-hand quadrant, the most destructive, very destructive. You understand? It's coming through this area, the winds are spiraling and moving in, and then you got the whole force of the tropical cyclone. The cyclone can cover distances of more than 300 kilometers. You understand? In fact, the whole size of the cyclone is around 500 kilometers. You understand? So more than 300 kilometers from the eye. The cyclone moves, all right, from east to west, southwesterly here. Can you see it? in the direction from the equator. There's the equator here, and it moves southwesterly like that. All right. The low pressure and the fast moving wind over the ocean masses cause a storm surge also. All right. A huge bulge in the sea water. You find those bulges occurring, you understand, over the sea. All right. And that's massive, can be meters high. Okay. Already starting to form its devastation. All right. Which leads to further flooding of the coastal regions that are hit by the cyclone, because remember, the force of the wind is lifting the water, is causing massive bulges, you understand, in the water. All right, so this is your destructive stage. Strong winds, torrential rainfall. All right, but we'll come to the cross section now. Okay, and lastly we have our dissipating stage. Okay, you'll notice the pressure starts increasing. It doesn't necessarily be 1,000 millibars and more. It still can be below, maybe 9 something. All right, you can have it slightly below the 1,000 millibars. But the fact is that compared to this, it's starting to dissipate. The pressure is increasing in the center. All right, I'll show you on a synoptic map later that we must be careful, we must look at where this cyclone is, but let's go step by step. Okay, so here now, when the tropical cyclone moves over land, all right, the wind is slowed down due to friction. It was a land surface and the wind, you understand, is no more the ocean. There's friction and the speed of the cyclone is slowed. Right, there is less evaporation due to less humidity compared to the ocean. You understand? The ocean has massive humidity. Now the land has limited humidity. It's drier. The ocean is, of course, the ocean. So therefore, there's less humidity, all right, to cause unstable conditions. Okay, because there's less humidity, less latent heat. Okay. All right. And lastly, if the cyclone moves into cooler subtropical areas, when it's cooler, what's going to happen? There'll be starting to be some more subsiding air. And what happens to the low pressure in the middle? It dies off. But your main factors are when it hits land, you understand the friction, and there's less humidity, so less latent heat. But it can go into cooler waters, and as it goes into cooler waters, more air subsides, that low pressure is gone because the pressure now starts to increase. The weather clears up, and of course, the pressure generally increases. So what have we picked up from here? It's that center. It's that eye. All right, that extreme low pressure in the center. The heat that drives this massive, massive cyclone. All right. If it gets lower in the middle, it'll be more intense. More air will rush in. You destroy that low pressure in the center, and the cyclone is gone, this tropical cyclone. All right, makes sense, learners? All right, let's go forward. All right, now let's look at a cross-section of a tropical cyclone in its mature stage. All right, now if we look here, this on the sides, okay, is known as the eye wall or the vortex. Okay, the eye wall or the vortex. Can you also see the upper air divergence here? All right, air is rising. It's creating a bit of a high pressure in the upper part of it, and of course the low pressure here because air is rising from here. All right, so let's look at this. All right, the eye wall or vortex. It's located on both sides of the eye. There's the eye here. It's located on both sides. It's associated with rising and cooling of air, resulting in cumulonimbus clouds. Remember, it's a mature stage. It's hot, all right? Latent heat is being pumped in. The temperatures are increasing. The air is rising at a rapid rate. And as it rises at a rapid rate, okay, there's massive condensation and massive cloud formation of vertical extent because it continues to rise and then diverges. And we can get clouds up to 15 kilometers or approximately even slightly more in vertical extent. Massive clouds. Imagine a cloud of 15 kilometers, learners. How much rainfall is going to bring? Torrential rainfall. So they experience heavy rainfall, you understand, torrential rainfall with the highest wind speeds as it's coming in there. Okay, so it's massive, heavy rainfall, high wind, very high wind speeds. You understand, hurricane force wind speeds, etc., of hundreds of kilometers per hour. All right, so that happens there. Okay, in the eye, it is calm. All right, it is calm and clear. It has subsiding air. Okay, because what happens is a low pressure here. Air is moving there. Some of the air comes back, subsides. As air subsides, it warms up, all right, resulting in no cloud formation, adiabatic heating, etc. So what's happening there is it's creating clear skies, all right, calm conditions, okay, high humidity, obviously, okay. So what's happening here? The tropical cyclones are calm conditions, clear skies, generally no rainfall. We may get some drizzle, but no rainfall, and high humidity. All right, it's approximately 25 kilometers in diameter. Okay, so as the system is passing and you are in the eye, don't be too happy. You understand, be cautious, because what happens here, the next vortex is coming in. All right, now as we move away from the eye wall, it doesn't just stop. There are more rain bands. Can you see it? All right, which can be more than 300 kilometers from the eye. It can extend outwards. It can still cause rainfall, etc. Okay, so that's your brief thing about the cross-section of the tropical cyclone. Out of interest, I know, please learners, do not learn all these figures off. Okay, I brought it as a matter of interest, all right, to show you this. All right, look at this. Tropical wave. Okay, a trough of low pressure. All right, is occurring. Right, then we go to a tropical disturbance, moving area of thunderstorms in the tropics that maintain identity for 24 hours or more. So it's starting, the disturbance is starting. Can you see it there? All right, now a tropical depression, okay, tropical cyclone with a maximum sustained surface wind of 61 kilometers an hour. So the pressure is getting lower. What do you notice now? It looks more white there. The pressure gradient is increasing. Can you see it? Right, increasing. And then there's a tropical storm, a tropical cyclone with a maximum sustained surface wind ranges of about 60 kilometers per hour. Can you see it's getting more serious? The pressure is dropping, pressure gradient getting steeper. It's growing in size. And you notice that white shows you the cloud cover. And then, of course, you got your hurricane, known as typhoon, known as tropical cyclone, with wind speeds above 118 kilometers per hour. Look at it now. It's intense. Pressure gradient is even more. Category 2, Category 3, Category 4, Category 5. And look at the Category 5. It looks like snow, eh? Complete, much bigger in size, more compact in terms of cloud cover, etc. There's your eye there. Can you see it in the center? It shows more clearer conditions. And now it is very intense. So you can judge these things. You understand? This slide I put in as a matter of interest for you to look at these different things, to notice what's the difference between a tropical storm and a hurricane, tropical cyclone, typhoon, all those names come in there. All right, category 5, very, very intense compared to category 2. Look at it there and look at it there. All right, these are strong, 300 kilometers an hour of wind, etc. We don't want that. All right, we are lucky in terms of that when we look at our country, South Africa, down here, okay, we have something down here that saves us a lot of times, the island of Madagascar. So what happens when it's moving here? It experiences friction, less humidity, and it starts to die off. But sometimes it's strong enough, it gains energy, and it can go past. But this stops many of them. And sometimes when it reaches here, it's a tropical storm. Okay, not a tropical cyclone. All right, because it loses intensity, okay, over this area. So for us, thank you, Madagascar, for reducing the impact. I'm not saying it in a funny way, and we hope Madagascar also doesn't get as many cyclones, but they help us a lot. All right, I want to show you something here, learners. Look at this. It's moving in. Can you see it? The tail here, sort of tail I call it. It's moving in. Can you see? It's coming here and going in. So it's anti-clockwise, isn't it? Anti-clockwise. So where is this? Northern hemisphere. NH. Because air moves in an anti-clockwise in the northern hemisphere around a low pressure. Look at this one. What do you notice here as it moves? Clockwise, southern hemisphere. Because air moves around a low pressure in a clockwise direction in the southern hemisphere. All right. Now look at this one, learners. Watch out. Look at the pressure towards the center. All right. Look at the pressure towards the center. It's still 996. Don't just jump and look at the cyclone, tropical cyclone on the synoptic map. Say, no. You understand? It's dropping. Okay, it's in the second stage. Look at where it is. It's going over land. All right. So therefore, it's dissipating. Okay. Now, look at the pressure gradient here compared to here. Can you see the difference? It's further apart here, the isobars, making it a gentle pressure gradient because it's starting to dissipate. It's moving over land. Friction slows it down. Less humidity, less latent heat. All right? Can you see it? And even the center is quite large. The eye is starting to dissipate. Can you see that, learners? That's how you must recognize things, at which stage it is. What is the cyclone, the number of cyclones that happen here? It's Ellen, A, B, C, D, E. I'm just demonstrating our normal letters of the alphabet. So it's the fifth one. All right. This is the symbol that is used. When you see the symbol, sometimes you say, how do you know it's a tropical cyclone? The name, the symbol, you understand? And yeah, it's showing you a movement there and there. It's showing you clockwise. You understand? It's moving clockwise. Okay, you've got that, learners? That's something to interpret. All right, look at the cloud cover in this region. Whoa, overcast. I will say, there's no term like this, very, very overcast. You understand? Because massive wind conditions. So don't think it also puts brakes, eh? You understand? When it hits here, it's dead. It will affect this area. Depending on the intensity, there'll be quite an effect before it dissipates. Okay. Right. We're lucky certain parts, a large part of South Africa is on the plateau. Then we've got the escarpments, so the intensity of the storm, you understand, also is limited more towards the coastal regions. Not that there's not an increase in rainfall over the plateau, but most of it because we have a narrow coastal plain, steep escarpment, and then going on to the plateau. All right, some things that you need to know in terms of relationship. A storm surge. A storm surge is simply water that is pushed towards the shore by the force of winds swirling around the storm. Okay, the force pushes the water onto the shore. Okay, remember these are high wind speeds. The advanced surge combines with the normal tides to create a hurricane storm tide, right? Big tides, and an increase of average level of more than 4.5 meters, higher than normal. That's massive. You understand? Most of us are not even 2 meters. Here you got an increase in those tides by more than 4.5 meters. All right. So another concept, inland flooding. In addition to the storm surge, high wind speeds, tropical cyclones bring torrential flooding in the area. Even after the wind has diminished, flooding potential still continues and remains for several days. You understand? Even the wind, because cloud formation, torrential rainfall still continues, so you get inland flooding. And of course, here we speak of escarpment if it's flatter. You understand? It'll go greater, more into the area, and there'll be more devastation over a larger area. Floods may destroy agricultural land, cattle, infrastructure, cause most deaths, drowning. You understand? So whether it's infrastructure, road networks, you understand, houses, all these things are damaged. You don't get piped water, okay, stagnant water, diseases spread, okay, economy is disrupted, people don't have jobs, sometimes you can't even go to areas and help people because of the massive floods and destructions of roads, etc. So it's a massive thing that happens when this thing goes on. All right. Then we talk about flash flooding. Flash floods are rapid occurring events. This type of flood can begin within a few minutes or hours of excessive rainfall. It just comes in. Okay. The rapidly rising water can reach heights of 10 meters or more and can even roll boulders, rip trees from the ground, destroy buildings and bridges. All these things get damaged. You understand? Right. So urban areas floods. Okay. This area floods and also rapid, although not quite as severe as flash floods. The streets can become swift moving rivers and the basements can become death traps as they fill water in. People go to the basement for safety. So, and you must remember the urban area has got less infiltration of water because of the concrete, tar, etc. So urban area floods. Some concepts that sometimes may pop up that we know them. Okay. Now, we look at some of the impacts of this tropical cyclone, the primary and secondary impacts. Let's look at what do we mean by this. Primary impacts or effects of the natural disaster are things which have been caused directly by the physical event. Okay, directly, as it hits, what damage is done. And tropical cyclones and will include direct damage due to high winds, flooding, heavy rainfall, storm surges. People are killed. That's direct, heavy storm during the storm. Destruction of buildings. So death, destruction of building, flooding, destruction of transport routes, destruction of the natural environment, erosion of the coastlines. You understand? It's going to be environmental, social, environmental damage to the natural environment, killing wildlife, social, people lose their lives, their homes, unemployment, economic, the amount of cost to undo here, plus there's less production in the country where the tropical cyclone occurred. So there's a lot, you understand? But this is the direct thing. So all those things now, it kills people when it hits. You understand? It damages buildings. It causes flooding. You understand? It causes destruction to the roads. Then we get the other thing that's coming, the secondary effects. And that's where your unemployment, etc., comes in. Okay, so we talk about the secondary effects. All right, these effects which follow from the primary impact. So even after the cyclone, we have situations. Okay, long-term homelessness, water pollution. In fact, sometimes there's more deaths after the storm or the cyclone than during, because stagnant water, pollution, waterborne diseases, people trapped with no drinking water, depending how well developed the country is. You understand? Poorer countries trapped, they die. You understand? All right, starve. There's so many things that can happen. Loss of jobs, unemployment, the insurance costs incurred. I mean, these guys are going to look at the fixing of this. If they insured, heavy costs, millions, sometimes billions of rands. Cost to government to sort everything out. All right, to bring out the social needs, to feed people a safe place. All right, mass migration away from the area. They have to move. Sometimes they come back. Okay, water and food shortages for the people. Again, it'll be more. Like if you look at this, there will be more in this country than this country. Because you can see it's a poorer country. You understand? Where you can see the buildings and people, they're here, it's a richer place. They may have money, more money to help the people. And that is why we need to look at some precautions. Okay, things like, number one, when the storm is going to hit an area, all right, we move the people or the tropical cyclone to higher ground. Why higher ground? Because the impact will be less at higher ground. All right, what else can we do to overcome this? Okay, we have early warning systems. Okay, put in place warning people about what's going to happen. Okay, so they can take steps to move away from the area. You can do GIS monitoring. When you're monitoring the geography information systems via satellite, you're following the path of the cyclone, you're updating the information all the time. All right. Other preparations can be having accessibility. All right. Roads cannot be jammed. You have roads open so that people can easily move out of the area. So you keep that. All right. People sometimes have food available. All right. For feeding. Emergency services like ambulances, hospitals prepare in case of any serious sort of people getting hurt, whatever, they can move quickly to those areas. So some of these are the precautionary measures that these countries have. South Africa may not have many of those things. Why? Because we hardly get hit by cyclones. All right. But countries that impact, you understand, they have these things ready. They monitor, they do many things. Early warning systems are put in place, etc. And there's educating of people why the precautionary measures need to be taken, not just blocking up your houses only with wood, etc., and limiting it, but also using these things. Some people even elevate their houses, you understand, where these tropical cyclones occur. So they put the pedestals down there and they raise their houses. But the other aspects that are discussed, like early warning signals or systems, higher ground, emergency service, accessibility in terms of roads, etc., are very, very important to try and limit the damage of this this tropical cyclones or hurricanes, as is known around the Americas, etc., to stop it. Unfortunately, learners, cyclones are increasing, and we call them the super hurricanes. Super hurricanes. Why? We also having global warming. And with global warming, there's a strong relationship as many scientists are saying, that because it's getting hotter, and remember the tropical cyclone relies on heat. So the higher the conditions, the more intense the tropical cyclone or hurricane in America. And we're finding more of those hurricanes occurring around the Americas, etc., because of the increase in temperature, and more intense hurricanes, category 3, category 4, 5, and increasing the numbers also. And we hope that this gets sorted out. You understand that the politicians take some steps, because we don't want to reach a year where we run out of the letters of the alphabet. You understand? And then have to start again with another system, okay, of numbers. All right, learners, I know I got quite carried away in the end, but this is quite a devastating force of nature. All the best, learners. Keep well. Goodbye.